Okay, we'll wait for 1 or 2 minutes and we'll start. So, yeah. Since many of you are doing internships and you may not attend classes, I don't want to miss this important problem solving sessions. This is quite interesting subject. So, I just want to reach this subject as much as possible. I know there will be at least 20 students waiting for me. So I prepare exclusively for you people. Yeah, I think my screen is visible. Somebody please respond by showing your thumb. Yeah. Mm, okay. I think is it visible now? Yeah. Thank you, Prajwal, Anushri, and others. Yeah. Thank you, Madalasa. Okay. Uh, Good afternoon, one and all. Welcome to another session on uh, modern information retrieval. Today, in chapter 2 of data modeling, we are going to discuss about Boolean modeling. So, as you people are aware, so that the goal of this modern information retrieval is the searching components, mainly works on searching components. User submits the query will process, and searching happens at vector space or probabilistic space, and of course that is based on group of indexed documents, and finally you get the rank, and based on the ranks that are matching, that will be displayed. So this is kind of predicting which documents are relevant to the user needs, and of course rank the documents in order to predict the likelihood of the relevance of the user. And of course, uh, you need model to encompass three things. One is for documents, so in order to store the documents. Second one for understanding the queries, processing the queries, and also for ranking functions. So yesterday we have seen there are you know uh, models. There are models, three kinds of models. So that is classical model, structured model, and browsing models. So browsing and structured are not there for you, which is out of your syllabus, but you have classical model. Out of that, the first model is Boolean model. So Boolean model, vector space model, and a probabilistic model. These are the three models that we are about to discuss in today's session. So I have already said in the yesterday's class, this is a slide taken from yesterday. There are several information retrieval techniques, out of which we are making use of some notations. So D represents the document, Q represents the query, F represents the framework. Framework is nothing but the model, and of course your R, QI, and DI. So what is QI? QI is an instance of the query. DI is an instance of the document. QI belongs to the queue, there is a set of queries, and DI belongs to a set of documents. And finally, this R function will give you some ranking. So this is a ranking function that determines the similarity between the query and the document and display the relevant information. So that is the basic idea. Now, when we talk about Boolean model, Boolean model, one thing you should understand, it is not a model based on ranking. So this is the only model which is not following any ranking. So Boolean model is a simple retrieval model based on set theory and Boolean algebra. Since the concept of the set is quite intuitive, and the Boolean model provides a framework which is easy to grasp by a normal user of any information retrieval system. Further, the queries are specified as Boolean expressions. This is the biggest challenge. All the queries you have to specify as Boolean expressions, which have precise semantics. So, given its inherent simplicity and neat formalization, the formalizing the Boolean model received a great attention in past years and was adapted by many commercial bibliographic systems. So if you look at, so they are working on only two things. One is documents, and the second one is queries. Queries are nothing but they are Boolean expressions. And remember, as I said, they are having commercial bibliographic systems. So they are used in libraries, especially in online public access catalogs, they are used. And our dialogue system means what comes to your mind? Any answers from the students? What is a dialogue system? Your chat gpt. So chat gpt, it works based on dialogue system, an intelligent system behaving, answering like human being. So it is a dialogue systems, and many search engines also you make use of this Boolean model. So what is that you have? You have a set of huge corpus of documents, and user uh, gives the Boolean retrieved model. He gives some queries. So if it is not in a proper format, what happens? It will filter out. use the heading for ranking the algorithm. Anyhow, ranking algorithm is not going to be used in Boolean, but of course, so it will give the results. User will certainly use it, and he makes use this is the flow certainly works. Remember one thing, Boolean model is the simplest model, and based on the concept of set theory and Boolean logic. When you think of Boolean logic, I think probably in discrete mathematics you might have studied this Boolean logic, the truth tables and all those things. So you have AND operation performed, or operation performed, as well as the NOT operation performed. So it was very popular during the 90s. So what are its main commercial use is it is used in Westlaw systems. So a large commercial legal search service. So any legal cases, if you want to search any legal information, if you want to search, so you are using Westlaw. This is one of the system. Still, it is using a Boolean model, and if you have a queue is nothing but query. So it has two terms, key terms, T1 and Ti and Tj, sorry. So you can certainly perform the intersection, or so here when you say it is intersection, when it is intersection, Q is nothing but so document with both the terms Ti and Tj are present in this particular document, then you can certainly make use of this expression. If your document is either this is and, actually this is a like this, if you write it as an and, probably I'm just making you to remember, and this is or operation. So document is either having T of I term or T of j term. So in the query, certainly you can write your expression like this. If the document without this particular term, so then T of I, then you can certainly write the tilde of or not of T of I. So you can certainly write. So not you can certainly represent in the form of, here I have represented it as a tilde, but you have a notation, Boolean algebraic notation, the not. Okay. So these are the some concepts that we are using in our system. Apart from this, we also should look at some of the very important terminologies. The formal characterization of a Boolean model. Q is nothing but it is user query, small q. Capital Q is a set of all the queries. D of I represents the document. So you may have many documents, D1, D2, D3, D4. So D of I or D of J represents. And every document is having index term, wait for index term wait for every document. So this is I is the keyword and T is the total keywords that you have for J document. So we can certainly write a weight of ij, that is I number of keywords in J the document. Either it will be 0 or 1. So it is 0 or 1. This is the thing that you are mathematically you are going to write. So you know very well conjunctive normal form and disjunctive normal form. Conjunctive normal form, sum of products. So whenever you have sum of whenever you represent sum of products, so you can certainly write in disjunctive normal form. The query is expressed in disjunctive normal form. So this is the only requirement. Even if you write query in if you give query in CNF, conjunctive normal form, it has to be converted into disjunctive normal form, DNF. So the DNF normal form, you certainly write it express like this. Q of DNF. So that is query is expressed in DNF form. So and each part of the query is represented as QCC. So query CC. So it is. And similarity function. Look at here, similarity function. Sim of D of J, the document of particular document, comma Q is equal to 1 if there exists QCC, there exists a query component where query component this should it should belong to the query in the DNF form, and the key term it should be present in G of I, which is yesterday we have seen G of I into D of J, that is equal to Qi of GCC. It should be present in the key term should be present in that particular document. So yesterday we have given this meaning. So the key term. So anyhow, it is well defined in the notes, so you can certainly make use of it. So the query contains Boolean operators like and, or, and not. So if the query is in disjunctive normal form, that is DNF, we can directly use it. That is, we can find out the similarity between the document and the query. So because this satisfiability of the formula, what we have seen in the previous this one. So this is the formula. I was just talking about similarity index. If you want to find, so you need the query should be in the form of a DNF, and if the query is in conjunctive normal form, so we have to convert it into CNF into DNF. So anyhow, we have some set of problems, numerical problems we will solve, and you will understand how it can be converting. So converting a formula to DNF, there is sum of products terms, involves logical equivalence, that's all. So it is very easy. Such as double negation, you can certainly do. Double negation elimination, De Morgan's law and distributive law, you can certainly use in order to bring them to DNF, disjunctive normal form. So now let us look at, if you have paper and pen, please write down this or take screenshot of this. So look at here, you have 5 documents given. In document 1, you have big cats are nice and funny. This is the content that it has. D2 has small dogs are better than big dogs. D3 has small cats are afraid of small dogs. And D4, that is document 4, big cats are not afraid of small dogs. And D5, funny cats are not afraid of small dogs. So these are the things. This is the thing. So first, what you have to do, you have to stem these documents and remove the stop words. What are the stopping words? So R is a stopping word, and is a stopping word, than is a stopping word, R again, off is a stopping word. So you can see these are all stopping words. You can certainly take not is a stopping word, afraid is a word actually. So you can see you can remove all these things. That is the first step. Later, what you have to do, you have to construct a document matrix against this terms, against these formulated terms. So you have to construct document matrix. This is a very important step, and these 4 steps are please note down, these 4 steps are very, very important. And the third step is check user query which is in disjunctive normal form. If it is not, you have to convert it. So later apply the formula and find the similarity between the query and each document by applying the similarity function. So similarity function, so you can certainly apply. So that is the thing. Now the step one, when I apply step one, stemming and stopping words should be removed. If I remove, what I get big, cat, nice, funny, small, dog, better, afraid. These are the words finally we got. These are the actual keywords we got. Formulated terms. These terms you write it like, in one side. So big is called K1, that is keyword 1. Cat is keyword 2, nice is keyword 3, funny is keyword 4, small keyword 5, dog keyword 6, better keyword 7, afraid keyword 8. Exactly. So now in document 1, if you look at the content, so it contains the keyword big, it contains the keyword cat, it contains the keyword nice, and it contains the keyword funny. So you can see that big is there, cat is there, nice is there, funny is there. Yeah, four terms are there. So you write four terms, one, one, one. Rest small, dog, better, afraid, these are not there. You can certainly leave it blank or you can write it zeros. So this is the first thing. Similarly, the document 2 contain big term. Yes, it is there. Then cat is not there, nice is not there, funny is not there. Look at there. Cat is not there. Yeah. Nice is not there, funny is not there. Done. Similarly, it has a small. Yes, it is small. Dog is there. Better you have. So, and you store. You write 111. Whichever the terms that are missing, you write 0. Similarly, for D3 against the key terms, so you just write same thing. You just write this is called the document and term against document, formulation of term against document matrix. So this matrix plays a very important role. First thing. Now, after these two steps, then you should look at what is that user is giving. This is fixed. So this document matrix is fixed. So it is fixed. Up to this stage, it is fixed. Next, what user is giving the query? User is giving the query funny and dog. Funny and dog. It is in disjunctive normal form. Yes, it is in either and or not or form. Yes, it is there. So finally, so your query DNF is funny and dog. So you have only one component. You don't have 2, 3 components. So if you divide the query is only one component. So QCC is one component. It is also the same. It is having only one component. That's component itself. It is QCC. QCC contains sub queries. So now, what are all the documents that are there? So funny is a keyword and dog is a keyword. So funny keyword is K4. Look at here, K4 is funny keyword. Dog keyword is K6. You write down K4 and K6. What are the documents it has? So you write D1, D2, D3, D4, D5. If funny is there, you write 1. If dog is not there, write 0. In D2, funny is not there, dog is there. So in D3 also, funny is not there, dog is there. In D4, funny is not there, dog is there. In D5, you have funny also, you have dog also. So you write this. Now, after writing, finding the similarity queries in each document, apply to similarity function. So you apply sim d of j comma q. If it is 1, so then there should be QCC component should be there, and this QCC component should be uh, should be there in QDNF. So since you have AND operator, that means both both the query terms should be present. Both the query terms should be present. So the key term multiplied by the G of document and G of QCC should be same. It should be there. So that means uh, the first uh, K4 is K4 and second K6 are two keywords that should return G of I QCC 1 1 as they are present, and hence D5 gets retrieved. So when you give this query, your information retrieval system will get you D5. D5 is the one which is matching with your query. So that is the thing. Similarly, so you consider again one more example. Again, for the same example, the stopping and stemming words, there is no change. They remains as it is. There is no change, and even the document is also no change. So the document matrix is also not no any changes are there. So because the document contains static information, so only the query gets changed. Now you take next query. So here funny and dog anyhow D5 gets generated. Now this was the earlier one. Now if the query is little bit changed, funny or dog, V is nothing but or. So when you think of funny or dog, so what happens? The query DNF is funny or dog, and your GCC QCC is funny or dog. So you write the same documents against the key terms. You can see 1 0 0 1 0 1 0 1 1 1. So in this case, if you apply G of I to every QCC query components, everything that returns 1 1 is present in all the documents. Either funny should be there or dog should be there. In such cases, D1 also contains, D2 also contains, D3 also contains, D4 also contains, D5 also contains. So all the documents contains funny or a dog if you want to search. So all the documents contains this. So D of 1 to D of 5, all the documents satisfy this. So it is done. So it is displayed. This is retrieved. D1 to D5, all the documents are retrieved. So they gets retrieved. Next, I write a little complex query. I should have, now I'm using 3 key terms. Look at here, big and dog and not of funny. So funny, if it is present, you have to write it as not. So you have to make it inverted, not of funny. So this is your QNF term, and this is your GCC. So QCC, yeah, same thing. Now apply the same thing with all the documents on you write. K1, if dog is big is present, write 1. Big is present, yes, right. Big is not present, is write 0. big is present, you can write or itself. If it is not present, write. Same way, dog is also present, you write. Not funny. If funny is not present, you write 1. If funny is present, you write 0. If funny is present, 0, because you are taking not of funny, not of funny. So you write it. And same way, D4 also, not a funny. Yes, if it is not present, you write 1. If it is present, 1. And here also it is. So finally, you should get, it should have, finally the result of this is 1, 1, and 0. So this should be there. So it should present big also, it should present dog also, and it should not contain funny. It should not contain funny. So the document that satisfies this 110 is here. You can see D2, which satisfies 110. So it contains big, it contains a dog, and it contains funny. Yes. So it does not contain, it should not contain funny. Yes, it is there. And even D4, yes, even D4 also. You can see it is containing big, it is containing dog, but it is not containing funny. Yes. So hence, so 110 is matched with D1 and D2 and D4. So D4 and D2 documents gets retrieved. So this is, so in the internal, in the examination, I'll be giving uh, data, that is documents, and set of statements. You have to stem, and you have to remove the stopping words. Then you have to make key terms, and later you have to construct a document matrix, and uh, document index matrix you have to construct. Later you have to find the similarity between the query and the document. So query will be given like this. So you have to write all these steps, and you have to finally come to know, you have to deduce what are the documents that are gets retrieved. So that is the thing. Now I give little, complicated one. You can see cat and nice or afraid. So this is not in a DNF form. So DNS form, it should be, it is in CNF, conjunctive normal form. So I have to convert it into DNF. So very simple. Multiply these things. Multiply cat, cat and operation with nice, cat and operation with upright. Both the results multiply, or it. So that is the thing. So nice and cat and nice, cat and afraid. Yes, it is done. Cat and nice, cat and afraid. This is one QCC, Q component, Q searching component. So this is a Q searching component. So query searching component. So there are two query searching components. They should be, or either first component should be present or second component should be present. So either cat and nice should be there, or cat and afraid should be there. So you deduce the similarity function, and find out which documents are satisfying this. So take, so the same thing. First you work with the cat and nice. So cat is nothing but K2, nice is nothing but K3. Cat is K2, afraid is K8. So which are the documents that are holding that keywords? So cat is present in document 1, cat is present in document 3, cat is present in document 4 and document 5. So nice is present only in document 1. So the here the output should be 1 comma 1. So 1 comma 1. So D1 is selected. D1 is selected. Now similarly here, look at here, cat and afraid. So D1 does not contain afraid keyword. Yes, it should be both. D3 contain cat and afraid. D4 contain cat and afraid. D5 contain cat and afraid. So all the QCC that are satisfying 1 and 1, 1 and 1. So in the first QCC as well as in the second QCC, you should combine together because it is an OR. It's a combination. So you combine them, you write. So D1, D3, D5, D5 are the documents that are retrieved. So this is one example. So hope it is understood by everyone. So if you have understood, if you have any doubt, please let me know. Sorry. Yeah. Is it clear? Thumbs up, thumbs down, thumbs up. Is it clear? Yes. Imtiaz, Vishnu, yeah, yes, good. So I think some students are, really attentive. Hita Prakash. So you are, yeah, many are doing. Yes, Madalasa, Anushri. Yes, everybody. Good. So let me work on the second example problem. I'll take one more example problem. So this example problem is all about, see, I have only 4 documents. So this is another exercise. 4 documents I have. So computer information retrieval is the first document content that it holds. Second document, computer retrieval. Third is information. Fourth is computer information. Luckily, there is no stemming word, there is no stopping word. So first step you can just skip because there is no stemming and stopping word here. So directly you go for document matrix, term document matrix. You go for term and document matrix. Done. Only 3 terms: computer information retrieval. So look at there, computer information retrieval. That's all. So only 3 terms, very easy, very easy. And what are the documents that it holds? You just write it, K1, K2, K3, write the matrix. Yes, done. Now check the first query. Query is information and retrieval. What are the documents that contains information and retrieval? So information and retrieval, that is K2 and K3. K2 and K3, what are it is holding? So D1 is holding. Yes, D1 is the only document that is retrieved. Look at here. But actually you cannot write straight away. You have to follow the same steps. The QDNF is equal to information uh, and retrieval. So QCC is also information and retrieval. So find the similarity between the query and each document. So D1 gets matched because G of I QCC is 1 comma 1. So that is the thing. So D1 is the only document that satisfy this. They present. So D1 gets retrieved. So this is first query. Second query. So second query, if you look at information or retrieval, in this case, so QDNF is information or retrieval. Of course here, yes, information or retrieval. Yes, it is done. So now it is or, I'm sorry, it is or, there is a mistake. Okay, information or retrieval, if you look at, so if you look at this, either these two, 1 1, this is uh, this is also 111111. So all the documents, or means all the documents gets retrieved. So that is quite common. It is or so what are all this you know keywords that are matching K2 or K3, they are all displayed. Now, again, I give information and computer or retrieval. In this case, I had to, this is in the CNF form, I had to convert it into DNF form. Uh, so if I convert it into DNF form, so what happens? Information and computer or information and retrieval. So find out the GCC, find out the GCC for sorry, QCC for each term. So here D1 is the one that satisfies 1 1, D4 is the term that satisfies 1 1, and here again D1 satisfies. So D1 and D4 altogether, they satisfy. Yes, those two are the documents that are retrieved, So if you look at the advantages and disadvantages of this method, very simple. Boolean model is very efficient as well as very easy to carry out, very simple to understand and explain. Work nicely when the searcher knows exactly what they are looking for, but it has a disadvantage. There is no ranking. That is very difficult. If 2-3 documents satisfy, so which one should be selected first? Which should be selected next? So there is no ranking. That is the biggest problem. It is difficult to write good Boolean queries. Yes, that is the thing. And user, especially the lay user, he is unable to write good Boolean queries. Definitely there will be a problem. And documents are close to being retrieved or not retrieved. So that is one thing that you have to understand. So this is the advantage and this is the disadvantage. So these are the two examples that I have covered in this PowerPoint presentation. But in the notes, I have given two other examples. I just show that also. Modern information system, yeah. Notes. So in the notes also, I have given two examples. I'll just explain so that when you read these notes, so probably you will understand. Okay. So for your internal, you will have only module 1 because module 1 is such a big one. Module 2 is very small. Okay. Yeah. The same thing I have just explained, all these things, how things work, Boolean model, how exactly it works, I explained. Now, look at this, exercise problem. You have 5 documents and vocabulary of 6 terms. I have given 6 terms. What are the terms I have? So document 1 is having term 1 and term 3. I have not given the any keyword or anything. So document 2 is having term 1, term 2, 4 and term 6. Document 3 is having term 1, 2, 3, 4, 5, all the terms. Document 4 is having term 1, 3, 6. 5 is having term 3 and 4. Now, you write the matrix, document index matrix. Just write it. So term versus a document index matrix, you just write. Which are the terms that are present, you just write. Now, the query here is Find the document consisting of term 1 and term 3 and not term 2. So that is term 1 and term 3, not term 2. So this is the query. And this query is already in DNF form. You can see it is there in already in DNF form. So what you can do certainly is you can certainly write the term 1, not term 3, term 2 and term 3. So since it is AND operation, all three should satisfy. So what happens here? Document 1 is going to satisfy 111 and document 4 also satisfies 111. So hence you can certainly write, you can see all the documents that satisfies this is document 1 and document 4. So definitely document 1 and 4 are retrieved, are relevant to the query, so they are retrieved. So this is the way. So this is the way. And the second example, look at here. So I have another question here. So document another example. So here you take English tutorial and fast track. So stopping word is there. Learning latent semantic indexing. Book on. So there is a stopping word. Semantic indexing and advance in structure and semantic indexing. Stopping word is there. Analysis of latent structure. So stopping words are there. So first what we have to do, we have to remove these stopping words and you have to find only the terms. So if you find the terms, look at here. So English is a term, tutorial is a term, fast is a term, track is a term, book is a term, semantic is a term, analytics is a term, learning, latent, indexing, advance and structures are the terms. So these are the terms that are identified. So stopping words are removed. Yes, stopping words are removed. Right. So later, against the document, so you have to term document index matrix that you have to generate. So there are 5 documents, so 5 terms, so 5 documents. Against the terms you have to write, if they are present 1 or if they are not present 0. You just write it. It's the same way. Now so now we know 0 and 1 vector for each term. You can certainly write. Now the query is advanced structure analysis and the complement the last. Look at here. So we have 0 1 vector for each term. The answer to the query that we have taken the vector for advanced structure and analysis. The last one is complement the last. So complement the last and do the bitwise. This is what they have given like this. So advance and structure, not analysis. So you can certainly write I will have here. So you will have advance and structure and not analysis. So 3 terms. Look at here, 3 terms. So advance should be there, structure should be there, not analysis. Same thing. So apply the same. So apply the same to the document index matrix. So document term matrix. So you get 0 0 1 0. This is and 0 0 one for documents, and of course, so all are fetched. So finally, if you look at, so advanced is the first term, structure is the next term, and not analysis is the third term. So look at here, you get document 4 in everything. So and is also there, not is also there. So hence in some of the reference books they have written like this, don't get confused. So document 4 is retrieved because it is containing all the terms. So all the terms. So this is how you can certainly understand. This is how you can certainly understand. So anyhow, there are two more, models. I think tomorrow also I may schedule class at 7 p.m. So hope you will be free, right? Is it okay? 7 p.m. If is okay, give thumb. If it is not okay, just invert the thumb. Say your reaction. Okay. Yeah. I think Vishnu Kashyap has some query written. Sir, in the first step, we do both stopping word removal and stemming, right? Yes, exactly, Vishnu Kashyap. You're right. And so, indexing will become index. Yes, correct. Exactly. You're right. You're right. He has asked the question, but I have not noticed it. So yeah. So tomorrow I will schedule the same online session at 7 p.m. so that we will continue our discussion. So since this module 1 is very big, so I will take little time, and I'm going slow, so I cannot rush up the things. So I'm hope you are able to understand, right? So if you have any problem, just let me know. Personally, you can message me if publicly, if you don't want to disclose. I will certainly and if still, if you have any doubt, if you want to manually me to teach, so please come to the college. So now I finished a third semester and a fifth semester classes. So I am absolutely available in the department. I can devote my time to make you understand these concepts. Personally, I can teach also. So that is the thing. So anyhow, I'm not bothered about the people, those who are not joining, but I'm completely happy that at least some students are attending, and my efforts are for these students, those who are attending. So thank you. Let us meet tomorrow at 7 p.m. I'll share. The link is again the same link. Link is same link. The Google Classroom link, the same link. It is even the Google Meet link is also same. So there is no change. Right. So that's all for today's session. Uh, for preparing today's session, I referred these two textbooks. Christopher D. Manning and Prabhakar Raghavan, that is one textbook by Introduction to Information Retrieval, and another book, Modern Information Retrieval by Beza Yates. So this is the book that I have referred. Thank you. Have a great day. So see you in tomorrow's class at 7 o'clock. Thank you. Yeah. Please type in your USN for attendance sake. I want your USNs in the chat window. Please type it. Yeah. Thank you, Ananya, Anushri, and Vishnu Kashyap. Yeah. Thanks for all the students, those who have attended. At least I can see some 10 students, 10 to 15 students. No problem. Yeah.